Hello, good evening everyone. I warmly welcome you all to yet another YouTube live session organized by the SLIIT Mozilla. Today's session will be on Introduction to OWASP Top 10, and I'm Kani Gamalat and I'll be your moderator for this session. And the OWASP Top 10 highlights the most critical security risks for web applications. Understanding these risks is essential for every developer and IT professional. By the end of this session, you will gain more valuable insight on how to secure your application, protect your users, and avoid common vulnerabilities. This knowledge will be especially useful for your academic projects, internships, and future careers in software development and cybersecurity. Now, let me introduce our speaker. He is Hishan Karivasa, a cybersecurity undergraduate and also a dev team and editorial team member of SLIIT Mozilla. Without further delay, let's move to the session. Now, I invite Hishan to take over. Over to you, Hishan.
Thank you, Kali. I hope my screen is visible. Yeah. So let's start. Okay. So what is OWASP? Talking. So OWASP stands for Open Worldwide Application Security Project. So it was founded by Mark Kirby in 2001, but as a foundation, it was established in 2004. So it's a non-profitable global community that improves software security through standards, tools, and education. It's well known for OWASP top 10, the topic that we're going to talk about today. And then SAP, it's a tool that we use to automate and then test web application vulnerabilities. SA, ASVS, and SAMM, like those are frameworks, like standards, those provided by OWASP. So, and all the resources which are provided by OWASP are used by developers, security expert, enterprises, educators, and regulators. Well, so what is OWASP topic? So it's an industry recognized report which identifies most critical web application securities. It was first released in 2003. It's regularly updated and worldwide widely used by developers, security teams, organizations, and regulators. So, like the basic idea is what they do. They take a time frame and they'll conduct a survey within the time frame about the heavily exploit and the web abusements and all the security risks that happen in that timeline, and then they categorize those and they make a list with top 10 vulnerabilities that they found. So here, like the first thing you can see is 2017 one, and then this is 2021 one. So here you can see how the vulnerabilities are changed and then what are added newly to the list. So without further delay, let's start. Okay, like our first vulnerability is broken access control, uh, which is failure to enforce user permissions. This vulnerability allows users to access bypass, view and editing others' accounts and privilege escalations. So this exploit was happened in Facebook in 2019. They abuse the contact importer utility. So they leaked names, phones, emails, birthdays, and locations. So those data was published on hacking forums and all. So it's something serious. That's why it's in like first place of the top 10. For the mitigation part, what we can do is we can enforce access control server side, which means when so I have seen most of the time, imagine this is our front end, this is our front end, and this is our back end. So, in the front end, there are tools which we can inspect our web application and our dependencies and logic, and then we can intercept our request too. Imagine we do front end validation only. Like, how can I say? As an example, take a username. So we know usernames are unique, always unique. So we put a username called admin. So this should not be allowed. So if we validate front end only, like from the front end we send a request to DB, and then we check whether we got admin or not. Okay, so let's imagine we had an admin as a username. Then we send it to the backend. Like imagine we manipulate the request by burp suit or a summer tool. Then we send it to backend. So this user can log in as admin. So this is what this enforce access control server side means. And deny by default. Imagine you are a user, you are a developer, and then user registered in your app. Then what if that user had admin access by default? So what you have, like best practice is to deny like the permission by default, which means if it's a user, the user might only can view the data in your website and their profile data. They might change the password and all. That's it. But if you want to escalate the privilege, I mean make that user admin, some authorized person should manually do it. So that's what deny by default means. Validate record ownership, limit cross-origin resumption access. I hope like everybody know what CORS is. And log failures and monitor. Use short-lived tokens and session invalidations. So this thing, the use short-lived tokens and session invalidations, it's a so imagine you go to a coffee shop or something, or else imagine a communication or something. You logged into their machine, and then you forget to log out. If that token or session is not short-lived, after around like day or two, that people who use that machine can access your account. Okay, so that's why we need to use short-lived tokens and invalidate the session. Which means, so imagine if you logged in and session or token is stored in your browser, and then you forgot to log out. But if the token or session is short-lived, which means the maximum lifetime is 5 minutes, if you forgot to log out and you went, it's fine. After 5 minutes, it automatically logged out, and the token will invalidate. So the other people who use can't access your account. So I'll show a small demo about this. All the vulnerable machines that I'm using for demo purposes, you can find them on the chat. The links are available there. Let me start the Docker container. So like, imagine like this is a simplest, like one of the many and the simplest way of exploiting this vulnerability. So the type I am going to demonstrate, it's not that common, but still it's available. uh, just take the idea or the concept, so then you can find all the vulnerabilities. Okay, so imagine this is your login. Okay, you log in as your username and then password, and here you can see in the URL we got an ID. I hope it's visible. Like we got ID here. So if our access is not controlled, anyone with this, if anyone, like imagine anyone can change this ID to get access of some other user. Okay, so I'll demonstrate it. So first, we have to check whether this got any kind of authentication. So what I'm going to do, I'm going to access this URL without logging in to check whether it's exposed. Look, when I access the URL, we can't access without logging in. So that means it do some kind of authentication. So that means if we inspect, there should be a session or a token which is responsible for that URL. This session or this URL. Okay, here. This is our session and this is our like key for the session. So what I do, hope this is visible. There's a tool called fuzz, FFUF. So we use it for fuzzing. Okay. So what I'm gonna do is I'm gonna fuzz this ID. So if there is anything, any other user account which like what I'm like the simple idea is I'm going to first this ID, then we can see whether what are the other available accounts or account IDs which are present in this app. Okay, so if I explain this command, this is the tool we're gonna use, FFUF, and U means URL. So what we're gonna first is this ID. Here for the word list, I am generating numbers between 1 and 0. So here is the cookie, like this thing. So what I do is I copy it here and then I paste it here. Look. So I pass this URL with the numbers from 0 to 100. When we pass, we can see all the available account IDs. So status 200 means, like it's available. So if I access this number by URL, just manipulate the URL, that's it. Look, we are administrator. So this is the basic concept, okay? So I think it's clear. So let's move to our next one. Second thing is cryptographic failures. So this is occurs when you not properly encrypted the sensitive data. Not only when storing, even in the transmitting too, you should not transmit plain text. You should transmit encrypted data and protected with weak algorithms. As an example, like MD5 and SH8256, those are weak algorithms, weak hashing algorithms. The reason is it take less time to hash, and they don't have any default salt or something. So what happened? There are a tool called Hashcat. What we can do is, since it takes less time to hash, we can brute force hash. So what's happening? Imagine we got a list of word we don't know, random list of word, or we can guess, we can make our own list of words, and then this is our password. Imagine like this is our hash that we want to crack. What we do, this is plain text, okay? Plain text, and this is hash. There are some tool like the very famous one is Hashcat. So this is Hashcat. Imagine Hashcat. We take this line, this word, and then we hash it. Then we check whether it's equal to this hash. We do same for this every single word. Then we can crack this hash. It take times, but imagine if you got some information about your victim, you found it open source intelligence or something. This is possible. And then in MD5 algorithm, there was a known issue, which is like normally in hash, if it's A, it generates a unique hash for this. So For A, it's universal. I mean, like wherever we encrypt hash with hash A with MD5, it gives us the same result. Okay, but there's a issue which, imagine for A, it gave us as an example. Imagine 1, 2, 3, 4. For B also, sometimes it give 1, 2, 3, 4. This issue was really serious. So this actually happens. That's why people don't use MD5 and SHA-256 very often. So these cryptographic failures can expose our passwords, credit card numbers, health records, personal information, and many more. So again in Facebook, okay. So there was a real world scenario which Facebook didn't encrypt or hash user passwords. They were stored at plain text since 2012. Okay, so there was a researcher who explained this online, and then he exposed that they didn't do encryption or hashing. There was no any intentional abuse, but there was a risk. So to mitigate, encrypt all sensitive data at rest and in transit. Apply authenticated encryption, disable weak protocols, FTP, SMTP, store password using strong salted hashing, which is bcrypt and Argon 2, enforce TSL with HSTS. So encrypt all sensitive data at rest and in transit. So, what data in rest means, the data in our DB, we have to encrypt. It's a common thing, we know. But what means by in transit? Okay, this is our web browser. This is our user is here using our web browser. And this is our server. You go to login page, okay? And then you enter your username and password. Then you send the request to login. If you don't use encryption in transit, uh, TLS or something, any encryption algorithm, what happened if there is an attacker who is in the middle of your network, who, they can see this plain text. This is why we need to use encryption when we transmit data. And this is why we need to check whether our sites got HTTPS. This S, it's one thing that we can guarantee that it encrypt and hash data, encrypt data in the transit. So that's why we need hashing when we transmit it. So I'll show a demo. I'll use my same application that I use. For this demonstration, I'm using a tool called Burp which is built to test web applications, and we can do a lot of stuff with it. It's a really great tool. If you're into web security, like you should master this and swap OWASP tool too. Okay, so I will turn on the proxy. So I'll intercept the traffic. So normally this is what going to happen. Like people can't use burp suit in your network. What they can do, there are some technical man in the middle attack or ARP poisoning. They can use those techniques to exploit this vulnerability. I'll show. So imagine you type your password as user and password as pass. When I log in, user, if it's not encrypted, we can see your username and password as plain text. So then the attacker can log into your account or get access of your account. Imagine, okay, like if you use any encryption algorithm when you're transmitting data, imagine like Facebook, let's say. So I turn insect on, then I just type user and pass, check. Here, where's it? Here, check. uh, our email, we can see its user, but our password, they store as encrypted password. So, which means in the transmission, they encrypt our data. So it's a good thing. So attacker can't access it. Like even an attacker intercept this request and then they found our password, they can't like decrypt or crack this to get our original password. That's why we need encryption in the transmission. Let's move on to the next vulnerability. Next vulnerability is injection. So injection occurs when untrusted input is sent to interpreters like SQL slash NoSQL, OS command, LDAP. Uh, so if our app have this vulnerability, attacks can manipulate queries or command, access or modify sensitive data. And before, there was two type of injection. One was SQL, another one was XS, which stand for cross-site scripting. But now they combine both into one and they make one category called injection. Okay. So I hope everybody knows what is Fortnite. There was this vulnerability, but it wasn't abused. The Epic Games did patch it before a large damage. For the mitigation part, first thing, never trust user input. Like we can't say our user will input exactly this. No, it never gonna happen. They're gonna abuse. There are people called pen tester. Like their hobby is to like fast the inputs and search feed. They input random data and they check whether this gonna break your app or not. So never trust. Validate and sanitize all input on the server. This means imagine we got a input field. If we send HTML tag or else JavaScript tag into input, our server should sanitize those. The server can remove those tags and all. Then only we can use that request. If we didn't sanitize, like it's a huge risk. Use parameterized queries or RM2. Test happen with security tools. Like there are some security tools. Like I'm not gonna dive deep into this. I'll demonstrate both SQL and XS vulnerabilities. Let me turn on the Docker kernel, Docker container. Okay, it's turned on. So I'll access. So I'll first demonstrate the SQL injection. So what I do is I enter my username and then my password. So here, if it's correct, it gives us a response back. What if we don't know And what if we don't know the password and in this application have SQL injection vulnerability? What they can do is they can type like I put an hint here, so it's easy to you can explore this vulnerability and practice. So I just copy this. We input this query to here. No, put it here. For the password, we can type whatever we want, or we can keep it blank for whatever we want. So it gives us a look. It gives us access. Whatever we put here as password, it gives us access. So what's happening? I'll demonstrate with the terminal. I hope the terminal is visible. So the query that I use is this. So from users, we selecting a user with username admin and password like our actual password. So it gives us result. But if we use the wrong password like just 123, no result because like there's no user with that username and that password. When we inject SQL, what's gonna happen? What's gonna happen is so in SQL for the comment we use these two dash commands, these two characters like two dashes. So the SQL, the server will think, this person wants username with admin only. We don't have to check the password. So what the server does, it gives the user account or the data with the username admin without checking the password. Look here, we got it without the password. Even if I give a wrong password, I give this, it gives us admin detail. So this is the concept. This is really tricky and very very tricky. You need to think a bit, and if you master in SQL, this is really easy for you to abuse. So this is SQL injection. So I'll demonstrate about cross-site scripting tool. This happens when we don't validate user input again. Imagine, if you remember, I told we need to sanitize user input. Imagine if user here input like this is this is what developer expect user input, just a text. Okay, what happened? It's fine, no issue. It renders good, working good. If they don't sanitize, what happened? User can inject. Here, I have to say one thing. This injection depend on whatever the stack they use to develop this app. If it's PHP, we could inject PHP. If it's imagine JSP, we could inject JSP. And if it's Ruby on Rails or Go, the injection type depends on the stack that you use in the web app. So imagine now I'm injecting HTML query like h1 test. Look, it renders it. So what user can do, what attacker can do, they can inject some malicious code. It might be vary. So the most common thing is what they do, they inject some code into these vulnerable applications, which whatever the password they end, that password will send to attackers server. So I'll demonstrate like very very small script. It's a JavaScript actually. So I'm injecting this. Look what's gonna happen. Look, our web app. It's like wiggling. Even you, even you refresh the app, it not gonna recover. Even I open another browser, look, same thing is happening here. So this is the concept of injection and especially cross-site scripting. I hope you understand. I hope there's no issues. Let me turn this. Okay, let's go to the next one a bit. Insecure design. Uh, Fine. So what is insecure design? Security controls missing or poorly planned from the start. This thing, I don't say this is mostly mistake in developers. It's not. So it's about planning mostly, critical thinking. Perfect coding cannot fix design flaws. So, as an example, weak authentication flows, unprotected credentials, wrong assumptions about user behaviors. So, what this mean? If you think this user will input password only 2 times or 3 times, it's a wrong assumption. It's not going to happen. So, if you turn, as an example, if you don't rate limit the login attempts or whatever the HTTP request, it might be can be get, post, delete, or update. If you don't rate limit, we say it's a insecure design, flaw in your design. So again, Facebook, there was this vulnerability, insecure design, hijack user account without password. Okay, so Facebook failed to validate client server data integrity, so that attacker allowed to change the data of the user while it's in the transmission, so they can get access. So for mitigation, plan security from start. So usually in software engineering, we use agile, like Kanban or Scrum to plan how we're going to build, and we follow SLDC. For security also, we have to follow some steps. That's what plan security from start means. Use threat modeling and secure design patterns. Follow secure development lifecycle. Similar to software development lifecycle, there's something called secure software development lifecycle. You can look up on it on Google. It's simple really. Validate critical flows with unit slash integration test. Segregate system tier slash remit resources. So this is something we have to keep in mind. Imagine if your backend got a function which take around, just imagine 1 minute or 30 seconds to do, like use CPU time. If you don't limit that resource usage, what attacker can do, attacker can send repeated requests. So for that same session, if you are running on a server, imagine a local server, your local server gonna overflow with that usage. So what will happen? Your resources will exceed. So then your server will crash. That's why we need to limit resources. Integrate security checks into user stories. So you know what use stories in Scrum? What we do, we go for our users and then we ask what they want. So they tell a story, then we categorize it into priority, post condition, trigger, and all. For that, we have to integrate security also. Imagine if user want to say, okay, I want to delete an account. So you have to think how people will abuse this, the deleting. So it can be IDO attack. IDO means the one I did in the first vulnerability, that we changing the ID of the user, or it can be anything. So we can't say what this is the like flow to fix insecure design, or use follow these steps to fix insecure design. We can't say, because it depends on the way that people think. Okay. collaborate with security specialists throughout the development. This is why if it's a software company, we need a person who is specialized in cybersecurity. Um, okay. I'll show a small demo. In this demo, I'm gonna like show rate limiting. So how rate limiting will help us to improve our security design. Let me start the Docker container. Yeah, start. So I made two separate URLs, one with the login limit, like rate limit, and one without rate limit. We will see. First, I'll show what's gonna happen if you don't have rate limit. For this demo also, I'm gonna use that tool called FFUF, which we used to fuzzing. So if I show you in login without limit, we got an login form. So I'm gonna brute force this login form with FFU. So what's happening? I specify the URL and then content type. It's a form encoded, form URL encoded, and as an input we send username and password. Look what's gonna happen. Okay. So if we don't have rate limit, I hope the screen is visible. If we don't have rate limit, attacker can brute force password one by one to the same account. So, so what I did here, for the admin account, I brute force passwords from a word list. Like I generated a random word list. So what happened? You can see for the password 123, no access. For let me no access. But if you check this status code, you can see for admin 123, we got access. So this is what happens if we don't have insecure design. This is one of the way that attackers can abuse this vulnerability or this flow brute force. Okay, I'll show you what happened when we use rate limiting. Here I'm doing the same thing. I hope it's visible. Visible, right? Okay. So what I do, I brute force this URL with rate limiting. So when I do the attack, you can see I need to change the RB. Look. So in the previous response, you can see it was 401, which we use when we don't have access or failed authentication. And here everything is 401, and then the correct one only, it's status 200. So when we use rate limit, after one or two requests, you can see service not responding to this request. For admin 405, welcome 405, and for admin 123, which is correct password, for the correct password even it says 405 because it enabled the rate limit. So attacker can't brute force. So this is the key concept, and this is one of the many ways that attackers can abuse this flow. I hope it's clear. Let's go to the next vulnerability, security misconfigurations. This occurs when system/apps have insecure default. Uh, Imagine in most of the Linux machines, root account is stand like username for root is root, and the password for the root account is 2T-O-O-R. If we didn't disable that thing or change the password, attacker can log into our Linux machine or server, whatever. Missing updates, unnecessary features, overly detailed error messages. So overly detailed error messages, that thing mostly happen on Flask apps. The reason developers forget to disable the debug mode in the Flask app when they deploy. So if they forget to disable debug mode, what's going to happen? Attacker can see what's happening inside, why the attacker having errors and all, so they can exploit. So that's why it's no it should not we should not over detail error messages to clients. Imagine if it's wrong for some reason, password is correct, incorrect, password is incorrect. We should show it's a common thing. We should show credentials incorrect only, not the username is incorrect, not the password is incorrect, or else we can't find the account. Not that, or uh, we only have to show authentication is failed or something. Very small error message. So this vulnerability can expose sensitive data, and this vulnerability can get unauthorized access to our servers. If we didn't like default passwords or default user accounts, attacker might get full server access also. So in 2019, there was a very popular banking giant called Capital One. They used AWS S3 bucket. So there was a misconfiguration in that bucket. So 100 plus million user data was exposed. So it's happening actually. Okay? So it's very serious thing we have to keep in mind. So authentication, harden systems, remove unused features slash default account. This is what I told before. We had to like turn down what are the features that we don't use, and then it's a must to remove or change password in default accounts, and disable directory listing and unnecessary services. What this means, in Apache servers, there was a vulnerability that if user access a wrong URL, it shows us all the files in the directory. So what attacker can do is they can check for environment variables, API keys, and whatever the thing is exposed there, attackers can see. So we have to remove that. Review cloud permissions carefully. So in Oracle, I mostly use Oracle. In Oracle, by default, every port is closed. We have to open that. Open like port using IP tables, and then Oracle use separate VNC. We using that we have to open the port. So when you're using any kind of cloud service, you have to review what are the permissions default for that server and all. uh, you have to use security headers and automate checks to detect and fix misconfigurations quickly. So automate checks means, imagine if you go to FTP server, if you enable that anonymous login, you know what's going to happen. User attacker is going to log in with anonymous credentials. So there are some tools, pre-made tools that you can use those to prevent those checks. So for this, like I don't have any demonstration. So I'll go for next vulnerability, vulnerable and outdated components. Okay, here what's happening? This is very common. So actually, people doesn't give much attention to this. If you're using npm, I am sure you might face into like a red color warning that this package you installed have vulnerability. developers ignore those. Like it's very common. They don't care about the vulnerabilities. Like it's giving the warning, but they bypass those. So that's a bad thing. So this vulnerability occurs when software libraries or dependencies are unpatched, unsupported, or have known vulnerabilities. Uh, if our application got this vulnerability, we got risk of remote code execution, which means user can execute malicious code in our application by exploiting those vulnerabilities in the dependencies, data breaches, and privilege escalation. So Equifax, there was a they use Apache Strut 2 for their web app. So there was a component which is outdated. So because of that, they got hacked and they got this much user data exposed, like 150 million plus users. And not only web applications, if you're using IoT devices, I guarantee people don't pay much attention about those. Whether they got security patches, they got vulnerabilities. If you got a IoT device, that's it. Users don't care whether they got updated or not. It's a huge security risk. So we have to keep that in mind too if you are working with IoT. For mitigation, maintain an inventory of components and version. So what this means, we have to the uh, the inventory means if you got a stock, you keep an inventory. Same thing we have to do for our libraries and our dependencies that we use. If we use choke, what we have to do, we like keep the version that we use and we find whether we got any vulnerabilities. We list those. And imagine if you use jest or something, and if you use TypeScript, you have to keep an inventory, what version and all. So it's easy to find which are vulnerable, which are not vulnerable, which we have to update. And so apply patches promptly means, imagine you're using some dependency and you scrolling on social media and you see this, or LinkedIn or somewhere you scrolling, and then you see this application or this dependency got this vulnerability. So if you found out that thing, instantly you have to apply the patches if you're using those dependencies or libraries. So you should like ignore those. I mean, oh, I'll do it later. No, it's not a good thing to do. Continuously monitor for vulnerabilities using tools like OWASP dependency check. There was a tool called OWASP dependency check, which help you to find vulnerabilities in the libraries that you use. Check it out. If you are a developer, you must use it. I'll show a demonstration. Let me turn on the Docker container. 06. So in this app, I use, is it visible? I hope it's visible. I'm using jQuery version 1.12.4. So in this specific version, there is XXS vulnerability. So which means if you use this vulnerability, if you use this dependency, there's a possibility that your application got cross-site scripting vulnerability. I'm intentionally using this library for demonstration purpose. If you're still using this version of jQuery, you should patch it or else you should upgrade it. So if you type and jscript like alert, look, it gonna execute. This is not a mistake of the developers of the app. your web application got this vulnerability because of a dependency that you take. So you have to keep in mind when you're using dependencies, always check for vulnerabilities and security issues. If not, this one small external dependency. So you can see when embedding jQuery, it's only one line, one small line. This one line can compromise your whole application. So, so that's why we need to keep eye on vulnerability details and the dependency that we use. So then let's go for identification and authentication failures. This occurs when app fail to properly confirm user identities or manage sessions. Weak authentication allows attackers to bypass login, reuse stolen credentials, hijack sessions. Examples: weak password policies. So, password policies means your application should have a policy which user must change their password regularly, not weekly. Okay, like for monthly uh, or every 3 months, there should be a policy. Without changing the password, users should not access the account. Like you should, if you're making an app, you can send an email, or when you try to log in, you can like prompt an error message telling you have to change your password. That's what password policy means. Missing multi-factor authentication, poorly managed session IDs. So in LinkedIn, there was an API breach which exploited because that public API didn't had any authentication. So attackers could retrieve like 700 plus million user data. So it's happening. Still, it's happening. I mean, not in LinkedIn. So this vulnerability is very common. Okay. So for in the mitigation, you can enforce strong password policies. Like I told before, you can tell users to uh, change passwords regularly, and length of the password, characters, everything. You have to make a policy for your application. Avoid default credentials. Uh, this can be what you told, like what I told. This can be for your Linux machine. Like imagine for root, the default password is TOOR. You should avoid those. And then if you're making an account, you should not use common exploited password like 12345 6. Like there are some common passwords. You should not use those. And then you have to use multi-factor authentication, protect login and recovery processes, limit failed login attempts, monitor suspicious activity, manage sessions securely with random IDs that expire after logout or inactivity. So here there are two things. One thing is identification, and other thing is authentication failures. I'll explain what this means. So we got a user here. So imagine username means username, password is pass. We got our application, a backend, whatever. What we do when user login, we check whether username and password correct. If it's correct, we send relevant response. This is what authentication means. It's simple. So what identification means? Identification mean this access or this login attempt, we have to check whether this is made by the original user. If imagine if it's me, if I own this account, I am accessing my account, I have used my username and password. But what if imagine this is my username and my password? What if there's an attacker, third person attacker? Attacker also use these credentials, and what if he also could got access to my account? This should not happen. This is what where identity comes in. We have to check these attempts made by the correct user or the original user. For that, what we use two-factor authentications or multi-factor authentication. Two-factor authentication, it's a must. You have to use it. Don't tell no one gonna hack my account. It happens. Without knowing, it happens. So it's a must. So when attacker tries to use my username and and password, our server will send request to my mobile phone or email, whatever, and then check whether I am accessing or not, like the original user accessing or not. If not, we can block this access. Otherwise, we can let this access happen and we can give relevant access to use. That's what identification and authentication means. Okay. Software and data integrity failures. This occurs when updates, libraries, or CD pipelines are used without verifying integrity. Uh, so if our app have this vulnerability, attackers can inject malicious code with untrusted plugins or libraries, exploit auto updates, abuse in-situ deserialization. So in SolarWind, it's an IT company. There was an attack which used exploited via supply chain attack. So if you're aware, you should know like there was an recent breach, like not a data breach, it's kind of a phishing attack which npm package two npm packages called choke and debug. What happened was uh, attacker sent an email to original developer of the choke and debug and then told that user to log in to their account. So that user told that email was came from npm. So that user didn't check whether it's valid email or not. He just logged in. Then those attackers got their credentials. What attackers did was they changed those codes and they added some malicious code into debug and choke. So almost every application who used that specific version of choke and debug got exploited. That's a very recent scenario which this software and data integrity failure happens. Mitigation, verify updates and data with digital signatures. So what is it, digital signatures? I hope most of you have seen when you download something, like below the download link, there is something called checksum, a hash, the hash value, like checksum and then a hash value. What that means, the original application, what we do, like normally what we do, imagine this is our file. What we do, we hash this, and we generate a hash value for this application. So when user requests this application, if there is an attacker in the middle of this transmission or in our network, what attacker can tamper or change the file. Imagine as an example, we are downloading a game. Okay, so when user click to download that game, what attacker can do is attacker can say, this person downloading the game. So what should I do? I should cancel this request and then I should send my request to this user. This user don't have any method to verify this is the actual game I downloaded unless the person runs it or like actual attack happens. For that, we use checksum. What we do, like imagine this is download link and this is our hash value for this app. What user can do, after they download, they can check for this hash function whether this file and the hash function given by the company or the original author is similar. If not, what we should do, we should delete it. We should download it again. And if we see like there's a suspicion activity, like whatever we download, the checksum is different, we can inform the original author of that website, or else we can do our network security check to check whether anyone is intercepting our traffic, or are there any poisoning, like those kind of similar attacks. We should check. Uh, that's what these verify updates and data with digital signatures mean. Use only trusted repositories. Uh, this means when you download, you should double check the source that we are downloading. If not, there is a I saw this post on LinkedIn. It's also a recent method. Okay, so imagine if we go to apple.com, what user just do, type apple.com and then go. If someone send you a link, what you do, we check, this is apple.com, this might be safe, I should click. Then you click and check the latest phones, or whatever. So then there's a new trend. It's not a trend actually. Like there's a way of exploiting, like a engineering attack, or uh, the way of phishing attack. Okay. What we do, instead of imagine the Unicode, the wait, ASCII. So for lowercase a, its uh, ASCII code is 97. Okay. Instead of this a, what attacker do? Attacker buy another domain with apple.com, but this a, like visually they both look same. Okay, but actually this is not ASCII 97. This might be Unicode, whatever number, but different. So uh, when we click that link, you can see there's no different. It's both apple.com, but this URL might be pointing to the a phishing site or an attacker site. So they might get your credentials and all. So always you have to validate the site or the repository that you accessing. Regular scan dependencies with OWASP dependency check Cyclone DX. Secure CI/CD pipelines with proper access control. Review code slash config changes before deployment, because sometimes for the ease of developers they hard code API keys. If that happen, sometimes our whole app gonna break or attacker can compromise. So we should double check, always review. Avoid sending unsigned or unencrypted serialized data to untrusted client. Okay, so let's go to our next vulnerability: security login and monitoring failures. This occurs when application fails to properly log, detect, or respond to suspicious activities. So the risk are breaches go unnoticed, attacks move silently, organizations lose visibility into incidents. Uh, Imagine you got a server, a web server. Someone is like sending repeated DOS requests. Here is your server. There is someone who's sending like huge number of like around thousand requests per second. If you don't have proper logging system or monitoring method, you aren't aware of this thing. So what this do is, this can make your app unresponsive for everyone, because it's sending repeated those requests and your server going to flood with requests. it go unresponding or it might crash. So this is why logging and real-time monitoring is necessary. Uh, in 2013, in Target, in their point of sale systems, there was a malware installed. The alerts was generated, but due to like poor monitoring, because it doesn't matter whether alert generated if that users aren't aware. Imagine you got a monitoring system or a logging system, it logs some suspicious activity, but if you didn't see that activity, you're not gonna know what you have to do. There should be a way that you should get notified instantly, like an email, uh, any kind of a notification way, like SMS, whatever. So this breach result exposed of 40 million credit card numbers and 40 million customer records. For mitigation, implement centralized logging for critical systems. So you can use Apache Kafka or something to do logging. So it's better if you are running, if your application running 3 servers, 2 servers, whatever, you should log everything at times. Sometimes they log user clicks also, like wherever you click, they look this person click here, and then all the requests where it made from, where it came from, and then what was the response time and all. Set up alerting and escalation process. So this means what I told. It doesn't matter. It's not enough if you got the alert if you didn't notice. So what you have to do, there should be a way that you should notice. Regularly audit logs and review for anomalies. If you go a system log, imagine for your server, if there's a system log, you have to regularly audit. You have to check it. What happened. You don't have to do it manually. There are some tools depending on the log. You can use those. It's easy actually, but most of the developers don't do it. Integrate security monitoring into incident response plans. This means imagine what if there was a DOS attack, what you're gonna do. If there's proper monitoring and proper alerting, you can block those requests. If there's no one gonna block it, your server gonna crash. That's what gonna happen if this vulnerabilities exist. I'll demonstrate this. I need to show you a cool library. You know, in Python, there is a library called scapy, which allow us to manipulate network packets. You can go into the packets and check who's sending, destination, and everything. So for the Go also, there something similar called Go packet. It was made by Google. This is very robust and very easy to use than scapy. So using this, I made a tool called Centrigo. You can find the link in the description for that tool. I'll demonstrate. So it's visible. I hope it's visible. Yeah, it is, right? Okay, so I'm gonna go it. So what happens here? When we run the tool, there are every like network directives that we can monitor. So what I do, I'm gonna monitor my Ethernet control. So now I'm currently connected to Ethernet. So it's just it. Okay. So now what I do, there's a tool called HPing that we can flood our network with ICMP packets. What I'm gonna do, HPing 3, I'm gonna, this is my Windows terminal, and this is my Linux terminal. Okay. What I'm gonna do from this, from Linux machine, I'm gonna make an attack for my Windows machine. This. Look, when I started the attack, instantly it started detecting the attack. So imagine if you want a custom monitoring or login method, you can use this Google Packet library and then you can make your own. Trust me, it's very, very easy and it's very useful. So, in real world scenarios, imagine your server, you detected you got this flood attack or something. What you can do, you can block. Not only flood attacks, I will just demonstrate with the nmap scan. So I'm using nmap scan. Wait, I think it's not visible. Here I'm doing nmap scan, service version scan. So here you can see there's an nmap scan happening. So what you can do is you can block those scans. That's what monitoring and logging. Uh, we that's what the way we have used monitoring and logging. If not, it's really it's gonna like affect our application. So last server side, let me close this application first. Where is it? So if you're interested, I highly recommend you to check on the Google Packet and the tool that I made. You can get uh, kind of idea how you're gonna do. And okay. So our last vulnerability or last topic, server-side request forgery. This occurs when an app fetches a resource from user-supplied URLs without proper validation. Uh, so by using this vulnerability, attackers can trick servers into accessing internal systems, bypass firewalls or network restrictions, access sensitive data or services. Uh, in Microsoft Azure, this happened before. So they could leak the access tokens, keys, and all by using this SSRF vulnerability. So for mitigation, we can validate and sanitize user input. Uh, First, I'll explain, then you will get an idea. This is our user, okay, and then this is our backend, and within our organization, we got some internal APIs. Or else, user might want to fetch something from an external URL, so we got that access to. So here are our some internal servers. And if user wanted, user can send a URL to fetch data from external resource also. So if you didn't do proper validation, what gonna happen? Instead of accessing those allowed servers, user can access some other private servers within your organization. Imagine this is a portal which only the admins can access. But if you don't do proper validations, uh, with this server-side request forge vulnerability, attackers might access these servers or services or APIs too. So that's what this first point means. Use allow list instead of deny list. What this means, imagine you got a server, you want to restrict access only to some specific domains or other services. Instead of allowing everything and then you type deny this one by one, what you have to do, you have to say allow list. Use this only. That's what allow list means. So always keep in mind, use allow list, not deny list. It's a really important thing. isolate internal services with network segmentations. So what does if, okay, imagine this is something our internal service, sorry, and it's in separate network. If an attacker send a malicious URL to access this service, because of this network segmentation, this request wasn't, it's not going to pass for this server. So uh, we can keep our application safe and block unnecessary outbound connections, disable HTTP redirection to avoid exposing raw responses, monitor outbound traffic for suspicious requests. Okay, I'll demonstrate, then you will get an idea. For this, again, I'm going to use burp soup. So idea here is we got an app. It's an web store. We running our backend here. Within our store, we got another API which aren't public. Only this can access those. And there are some private API endpoints. It can be API endpoints, services, or whatever, which this server should not have access to. By default, there should not be access. Okay, so here, when user search something, so this backend service use one of these servers to fetch data. So I'll intercept the traffic. Then if I search for, let's say, mouse, you can see this web app. Is it visible? Is it visible? Okay, I hope it's visible. So here, no, right, it's not visible. Oh, no, it does. It's not. Okay, I'll copy this and I'll show what happening. So what's happening is why can't I move? It's not allowing me to move. Okay. It's visible now, I guess so. So when user search, it use some external API uh, it uses some external API, some internal API to fetch data at user request. Okay. So what I'm going to do, instead of this URL, I'll change this URL to check whether I can get any response. So what I'm going to do, so I think here it's not visible, but the URL, okay, what I'm going to do, oh, I can't move. What I'm going to do is, instead of this URL, I'm going to use here /admin just to check. Okay. So I remove this internal /mouse part and then I type admin. So when I forward, wait, let's do again. Look, when what I did was, so I remove this part. Instead of that part, I type admin. So user accessing the admin API. So if you didn't had any proper validation or any proper way to control the access, if your application got server-side request 4G vulnerability, they can access some internal APIs too. This is the example this is demonstration. This is a simple idea. So here it's nothing, it's just return secret. But in the real life, this can return you your like company's admin panel or some secret data which you stored in like environment variables or else API keys. But so it's something you should keep mind of. Okay, so that's the end of our vulnerability leads. So as a conclusion, each of us top 10 risk shows how small flaws can lead to major breaches. So as I showed, small dependency, like just one line, can make your whole app break. Okay, so you should not take security as a small thing. It's a big part. So from the beginning, you have to plan how you're gonna secure and what will be the attacks that the attackers might do. You have to keep mind in those things, and you have to prevent those like as much as possible. So it's true that you can't make your app 100% secure, but you can do secure it for some extent. So always it's better to do your maximum. So real world cases prove the impact of ignoring security best practices. So think about Facebook, okay? Doesn't Facebook have like experienced programmers, security specialists? Even they do, still there are vulnerabilities. So think about a small developer, okay? So you have to keep that in mind. By applying strong design, validation, patching, and monitoring, organizations can reduce risk. So So this line, security must be built in, not added to later. Keep that in mind always. When you plan in an app, you have to apply security. In every single state that you are planning, you have to apply security and you have to do a security test. If you ignore, okay, let's say if you don't use encryption, you think, okay, I'll use this later, I'll do this later. Or else, like imagine your manager like giving pressure to you, deploy this, what you gonna do? Or you ignore validation or rate limiting, whatever. Don't do that. It's a huge security list. So that's a conclusion, and I hope you learned something from this session. And sorry if I did any mistakes. So let's go for a Q&A session. If you got any questions, now you can ask. Mm, what is Nmap scan? First, Nmap is a tool, like it stands for network mapper. Network mapper. What it does, you can scan about open ports, and if there's an open port, you can check what are the services that port running on the versions of that services. uh, if you go to server, you can check what's the version of that server, the OS, and you can embed some script to it, which it can automatically detect the vulnerabilities that running on those ports or those services or those OSs. So that's what Nmap. It's a very useful tool. Like people use it every day for penetration testing and all. So yeah. Mm, there any questions? I hope there's no any questions. So, how can I build the same tool like you have done? Okay. So, in the chat, you can see uh, GitHub repo of that app. You can find that thing and you can dive to the code and you can like get an idea how I did it. And it's really easy. And here you can find their documentations. You can refer that to. Give a try. Like, it's not hard thing and it's really easy. Here, if I showed you, so if I, as an example, if I show here, these are the detectors. Like for now, it got only four detectors, only three detectors. Okay, ICMP, Nmap scan, and SynFlood. Like if I showed you the source code, look, it's really easy. Like this is like here, from here, this is the only code related to capturing the packet. Okay, so after that, this everything after that is just a logic, the way how you gonna detect. This can be anything. Okay, like here it's just 66 lines. uh, Actually the function is only around like 22, it's about around 40 lines. You can see how easy it is. Okay, so as I told, this is how you access the packet. Just two lines. Whatever the layer you want, you can access. After that, you can make your own logic to implement the detection that you want. That's how I did it. You can find resources on online. It's easy, and the documentation also. So yeah, that's how I did it. Any more questions? I don't think there are any further questions. So I'll hand over to Kavini.
Okay, thank you, Hishan. And that was a really insightful session. And I'm sure everyone here learned something new today about application security and the OWASP top 10.
Uh,
On behalf,
there's a question. Is it support any layer? It does. Almost all, yes. There might be some limitations, but yeah, you can make it for any layer. You can do it.
thank you, Hishan. On the behalf of the SLIIT Mozilla, I'd like to sincerely thank you for dedicating your time and effort to educate us on such an important topic. And we wish you all the best in your future endeavors. And also a big thank you everyone who joined us today.
Thanks for having me too.